The automotive industry sells its vision of the future from one very specific angle. The reveal render always shows the car from the outside, looking lethal and low-roofed, perfectly planted on the studio floor. But take a seat in the back row, and that aggressive vision disappears. The passenger is trapped behind a narrow slit of a window, looking out from a melancholy, tightly enclosed space. Over the last 25 years, the main side glass, the cabin's primary lung and its only connection to the outside world, has been quietly shrinking. The vehicle waistline crept upward, and the windows gave way. The result is a total spatial disconnect. Modern vehicles are drawn to look expansive and open in the glossy sales brochure, but feel like a dark bunker to the people actually sitting inside them. The U.S. Department of Transportation and the Insurance Institute for Highway Safety measured exactly how much of the outside world has vanished. They tested successive redesigns of popular vehicles to see what a driver could actually spot within a 10-meter radius, and the data showed a steep 58% collapse. To understand the baseline, look at the 1997 Honda CR-V. The low beltline and tall glass gave the driver a clear view of 68% of the nearby scene. Fast forward to the 2022 model, and that expansive view plummets to just 28%. The Chevrolet Suburban followed the exact same trajectory. Between the year 2000 and 2023, driver visibility experienced an identical 58% collapse. The massive, measurable loss of the horizon has become a quiet, accepted casualty of modern automotive styling. If you ask the industry why the glass vanished, they point to hard physical constraints. Electric vehicle battery packs push the floor up, aerodynamics force the roof down, and side curtain airbags require thicker pillars. This diagram shows the literal squeeze placed on the cabin. As the battery layer pushes the seating position upward, the aerodynamic roof presses down, crushing the side window out of existence. But that explanation fractures when you look at a different class of vehicles. Over the exact same decades, sedans like the Toyota Camry and Honda Accord had to pass the exact same crash test and aerodynamic regulations, yet they lost under 8% of their visibility. Shrinking the glass is a deliberate styling choice, applied specifically to SUVs to create a sense of mass and make the occupant feel heavily armored. The story of that choice starts with a concept called the daylight opening, or DLO. This is the great swath of side glass that exterior designers use to make a car look fast and premium. But physical reality often gets in the way. When a designer's sleek, drawn line extends further than the actual glass can reach, because a structural pillar or a door mechanism lands right in the middle of it, the studio refuses to redraw the line. To fix the gap, the industry glues on a cheater panel. It is an opaque piece of stamped black plastic, shaped and textured to fake the appearance of a longer window. The absurdity of this panel is that it perfectly preserves the vehicle's aggressive proportions for a camera outside, but completely blocks the view for the human inside. It is the ultimate physical proof of a broken priority system, a piece of trim designed for people who will never sit in the car. 4 distinct parties dictate the shape of the side glass: exterior design, safety engineering, cost engineering, and the occupant. The exterior designer sees a high beltline and slim glass purely as a flattering premium graphic that enhances the car's stance. Meanwhile, the cost and safety engineers gladly accept a smaller window because stamped steel and painted plastic are vastly cheaper and easier to crash test than laminated glass. The fatal flaw happens during the sign-off process. The vehicle's greenhouse is approved strictly from low 3/4 exterior angles, where the shrinking window looks like a benefit rather than a cost. The single element responsible for how it feels to be inside the car is decided in a room where nobody is looking at the interior. The high beltline and the cheater panel easily sail through executive approvals because they look highly confident on a studio screen. It is a false victory. Years later, the actual cost of that decision surfaces far away from the design review. It hits a parent dealing with a car-sick child in the 3rd row, or an older passenger feeling completely boxed into a dark, slot-like cabin. It hits the buyer the moment they walk up to their expensive new vehicle and realize the sleek rear window they thought they paid for is actually just painted plastic. This is the inevitable trap. When a car is optimized entirely for the brochure, the striking look you chose eventually becomes the claustrophobic experience you sold. Solving this problem requires the industry to change the actual perspective used for design sign-offs. This is the exact problem Depix Design Intelligence targets. It generates photoreal evidence of the interior passenger experience before the 3D models are permanently locked in the computer-aided styling software. It forces leadership to evaluate the high beltline and the plastic cheater panel honestly, placing them side by side with lower beltline alternatives, entirely from the occupant's perspective. Exterior design can still be aggressive and premium, but those aesthetic trades must now be made with eyes completely open to the human cost. Use AI to see what the occupant will see before the glass is signed off, because when the render becomes the full evidence, a better decision becomes the product.